Hi, hello everyone. I am going to talk about equivalence of NFA with epsilon to NFA without epsilon. Okay, so there is an equivalent cycle where we are going to say all are equivalent, like NFA is equivalent to DFA, DFA is equivalent to NFA, NFA is also equivalent to NFA epsilon. Okay, and a regular expression is also equivalent to DFA, and from regular expression we can also get an equivalent NFA with epsilon, that equivalent cycle. So one of the equivalence that we are talking about is equivalence of NFA with epsilon to NFA without epsilon. So let us see. Okay, so basically what does this NFA with epsilon means? In this NFA with epsilon, we are going to make a move from one state to multiple states without taking input. So initially we say that in DFA, from one state on one input it has to go to only one state, that is DFA. In NFA, from one state on taking input it can go to multiple states. So whereas in NFA with epsilon is from one state without taking input it can go to multiple states. Okay, now NFA, when we are doing conversion equivalence between NFA with epsilon and NFA, is everything is same except the delta transition. Okay, now the delta transition, that what we are going to do is, without taking input from one state to another state, we call it, the term we call it as reachability, or we call it as epsilon closure. Okay, now first thing what we are going to do here is, we are going to look at this one, equalize transitions from one state to another state. Okay, now first thing is we are going to find epsilon transition. Now from NFA with epsilon we can get an NFA, but vice versa is not possible. So from NFA epsilon we take epsilon closure or transitions from each state from Q, that is called as epsilon closure. Okay, now in step 2 what we are going to do is, as the difference comes only in transitions, we are going to equalize the transition on this. Okay, NFA without epsilon from one state on input is equivalent to NFA with epsilon is nothing but epsilon closure of delta of epsilon closure on input. Okay, so step 2 is repeated for each input symbol for each state of given NFA. So by using the resultant state, the transition table for given equivalent NFA without epsilon can be built. Okay, so now let us say we have given here, this is given NFA with epsilon. So now what we are going to do here is, we are going to write it here from this given information. We have Q equal to Q0. There are three states, comma Q1, comma Q2. Q0 is the initial state and Q2 is the final state, and input symbols are 0, comma 1, comma 2. There are three input symbols. Now this is given NFA with epsilon. Okay, initial state is Q0 and final state is Q2. Now what we are going to do is, first step 1 is, we are going to find epsilon closure of each state. Okay, so there are three states, so write epsilon closure of Q0. Okay, so what in epsilon closure of Q0 is, by default every state is reachable to itself. Epsilon closure is reachability from Q0 state without taking input to what are all the states it can reach. Okay, so there is a directed path labeled epsilon from Q0 to Q1 on input epsilon. So now the machine, let us take it from Q0 state. So it can reach Q1 without taking input. It has come to Q1. From Q1 also it can go to Q2 without taking input. Okay, so by default every state is reachable to itself. So what we write it here is, we write epsilon closure of Q0 is Q0, Q1, comma Q2. So this is how you find epsilon closure of Q0. Now epsilon closure of Q1 is okay. So Q1 state, there is a directed path labeled epsilon, which means from Q1 state it can reach Q2. So by default every state is reachable to itself. So we say Q1 comma Q2. Okay. Now epsilon closure of Q2, which is Q2. So this is step 1. Now for each state, what are all the given states given in FA with epsilon? Okay, for each state you have to find the epsilon closure. So this is step 1. Okay, so next thing is what we are going to do is, this is epsilon closure. Now next thing what we have to do is, we have to find the transition for each state on input 0. Okay, so this is how you do it here. Now how many states are there? We have 3 states. Now we have to do Q0 on input 0, on input 1, on input 2. We have to find it out, because input symbols are 3. Q0 on 0, Q0 on 1, Q2 on input 0, Q2 on input 1, Q2 on input 2. Okay, this is how you are going to do it. So we prepare a transition table for this, and then we write it like this. So in a transition table we write it. So this is delta cap indicates NFA. Okay, and 3 states, Q0, Q1, Q2. What we have written above, the same thing we are writing in terms of table. 0 and on input 1 and on input 2. Okay, now Q0 on input 0. So that is this NFA with epsilon. Equivalent NFA without epsilon is NFA. This is NFA. And this is NFA with epsilon. Delta. Okay, now this is NFA. Okay, now NFA with epsilon, this is formula, epsilon closure of delta of epsilon closure of Q0 on A. So now first input we have to take is Q0 on 0. So epsilon closure of delta of epsilon closure of Q0 on 0. So what is first? We solve the inner bracket. So epsilon closure of Q0 is, we have already done it, which is Q0, Q1, Q2 on input 0 as it is varied. Now again inner bracket, delta of Q0 on 0 union delta of Q1 on 0. This one we are writing it, Q1 on 0, Q2 on 0. Okay, so finally we got it. Q0 on 0 is from the given NFA with epsilon, it's Q0, there is no path phi. Q2 on 0, there is no path. Finally outer bracket we are going to write it, epsilon closure of Q0 union epsilon closure of phi, epsilon closure of phi. Epsilon closure of Q0 is Q0, Q1, Q2. So we got it here, Q0, Q1 and Q2. Like this we have to do it on 1, we have to do it on 2. So 1 we have done it here, epsilon closure of delta of epsilon closure of Q0 on 1. So first we solve inner bracket, epsilon closure of Q0 is Q0, Q1, Q2. Now delta of Q0 on 1 union delta of Q1 on 1, Q2 on 1. So we got it here, Q1, Q2. Like this we have to do it for Q0 on 2. Next Q1 on 0, Q1 on 1, Q1 on 2. Next Q2 on 0, Q2 on 1 and Q2 on 2. Okay, so if you do it like this, what we got it here is, we have done it. This is the table, we got it finally. Now we draw NFA without epsilon. Okay, so there are 3 states. One is Q0, which is the initial state. Okay, next one is Q1 and next one is Q2. Okay, from the given NFA with epsilon, Q2 is the final state, so we are circulating it. Now Q0 on 0, it is going to Q0, Q1 and Q2. So Q0 on 0, it's going to Q0, Q1 and it is also going to Q2. Okay, next Q0 on 1, it's going to Q1 on 0 now. It is also going to Q2. Q0 on 2, it's going to Q2. Okay, now Q1 on 0, it's not going anywhere. Q1 on 1, it's going to Q1 and it is also going to Q2. Q1 on 2, it's going to Q2. Q2 on 0, it's not going anywhere. Q2 on 1, Q2 on 2, it's going to Q2. Okay, now this is the NFA without epsilon for a given NFA with epsilon.